Hello everyone, today in this video we'll be discussing the fifth module of machine learning, and in this module we have the following topics which is related to clustering algorithms and reinforcement learning. So we'll be checking what all the important concepts are there, and if you watch this video till the end, easily you can score more than 80% marks. Don't miss any of these topics, and before starting please do like and subscribe. It helps me make more videos like this, and if you have any questions you can DM me on Instagram here. So without wasting more time, let's get started. The first topic is introduction to clustering approaches. Okay, what is clustering? Cluster means nothing but a group. Okay, if there are a set of objects present and they are together, that is called as a one cluster. Okay, now in cluster analysis, it is a fundamental task of unsupervised learning. What do you mean by unsupervised learning? It means some set of data is given and the model is left to learn by its own. If there is any similarity or dissimilarity, based on that a categorization will happen. That is called as unsupervised learning, and if the categorization leads to the formation of clusters, it is called as cluster analysis. It is the technique of partitioning objects that are unlabeled. Okay, we don't know what the label also is there, just based on its similarity and dissimilarity will be classifying it. Okay, the into groups and clusters. An example of cluster formation: suppose this is the data given. Okay, how do you make a group out of it? If you make a group, this will be closer and this will be closer. Okay, like that two groups will be formed. Okay, so this is a cluster visualization. This is one cluster, this is one cluster. In another way also you can do, you can take this as one group and this has one group, this has one group and this has one group, this has one group, this has separate groups. Like that also you can do based on number of clusters. Okay, number of clusters matters. Now the centroid of the cluster is calculated by the mean value of points. Suppose that the points are 3, 3, 2, 6 and 7, 9. How do you find out the midpoint of this? What you will do, 3 plus 2 plus 7 divided by 3, 3 plus 6 plus 9 divided by 3. When you do that, you'll get 4, 6. That 4, 6 will be somewhere in middle of those 3 points. Okay, if these are the 3 points, the middle point will be calculated equally distant from each of these points. Okay, now difference between clustering and classification. In clustering, it is unsupervised learning. There is no label data and prior knowledge is also not there, and clustered results are dynamic. Here in supervised learning, there is a training and testing data. So data is already present. This is cat, this is dog. Based on that, the model will be trained. Okay, cat look like this and dog look like this. But in unsupervised learning, cat and dog is mixed here and it is not given. So based on the similarities, it will classify, okay, this is cat, this is dog. Okay, that is clustering. In classification, we have the label data, and knowledge of the domain must to label the samples of the data. Once a label is assigned, it does not change. But here the results can change based on if some cat is looking similar to a dog, that will be classified as a dog only. Okay, now applications of clustering: groupings based on customers buying pattern. If a customer goes to a shops and buys some items, and if the customer comes again, it is most likely that he will buy the same things again, right? Because of a similarity we are able to classify it. Okay, that is the first means application. Next is profiling on customers based on lifestyle. What is the customer's lifestyle? He will be buying such products. In informational retrieval applications, identifying the groups of genes that influence a disease. If one disease is there because of such and such genes, means if such and such genes are there, the disease is happening. So that can be identified as, if such genes is there, the probability of a disease happening is higher. Identification of organs that are similar to physiology functions. Taxonomy of animals, plants in biology, the behavior and demography, document indexing and data compression. Okay, now advantages and disadvantages of clustering. Advantage is that clustering algorithm can handle missing data and outliers. Okay, it can help classify the unlabeled data. Okay, if you use semi-supervised learning, it's even better. It is easy to explain the cluster analysis algorithms and to implement them. It is the oldest technique. Disadvantage is that it is sensitive and it is often number of clusters are to be specified by the users. Suppose if three types of data are there, okay, like cat, dog and giraffe, but we don't know what is the data present, then we give it as just two. So some giraffes will become cat, some giraffe will become dog, right? So that will be a wrong analysis. So we have to specify. That's one disadvantage. How many classes could be present, we have to specify that. Disadvantage: scaling is a problem. We cannot scale it to a larger level, and it is a designing a proximity measure for the given data is an issue. Means which measure you are using to see if it is similar or dissimilar, what factor you are using, that matters. Okay, now proximity measures are used to find the similarity or dissimilarity between the object I and object j. Okay, so the distance between the object I and j is always positive or zero. It cannot be negative. Okay, means if this is here, this is here, obviously some distance is there, it is positive only. Negative distances cannot exist in reality, right? So if d of ij is 0, means the object is itself at the same distance. If d of ij is d of ji, both distances are equal, that means it's symmetry. And d of ij is always less than or equal to d of ik plus d of kj. That means this is I, this is k, this is j. means this plus this distance is always greater than or equal to this distance, right? So if these conditions satisfy, then a distance measure is called as a metric. Based on this criteria, we have a few types of proximity measures. First one is Euclidean distance. This is the Pythagoras theorem, right? Here what we'll do, if you want to find the distance between xi and xj, we'll do xik minus xjk whole square summation till xk is equal to 1 till n and square root. Okay, if it is city block distance, we'll just subtract it and take the summation. Okay, we'll not do the square and square root. And is in type shift distance, here it will be the maximum of the summation. Okay, now let's take an example. If the two objects are given at coordinates 0 3 and 5 8, what is the Euclidean distance? 0 minus 5 means x1 minus x2 whole square plus y1 minus y2 whole square. Okay, and the Manhattan distance, it will be 0 minus 5 plus 3 minus 8, that is 10, right? And the chip shift distance is equal to maximum of 0 minus 5 or 3 minus 8, means we are just seeing if x is more or y is more. In this case both are 5, so the final answer will also be 5. These are the different types of measures, and this whole thing can be summarized using a distance called as Minkowski's distance. Here it will be the general formula. Okay, and if there are binary attributes, only zeros and ones, the normal formulas cannot be used, because in zeros and ones you have to use the binary attribute formula. Okay, so binary attribute formula we will be using the contingency table as given here. Okay, let's take an example, and also using by this contingency table we will find out the values of a, b, c, d, and find out the SMC, which is symbol matching coefficient, and Jaccard coefficient. Okay, these two things we will be finding out using these formulas. If we see an example, all the things will be clear here. So two vectors are given, the binary vectors 1 0 0 and 1 1 1. Now what you have to do, the first thing you have to do is compare 1 with 1. It is same or not? It is same. If it is same, means where in this table 1 and 1 comes? 1 and 1 comes in the place of D, right? 1 and 1 means D. So D has 1 point. Okay, 1 point. Next, 0 and 1. 0 and 1 has another point. 0 and 1. Now B has 1 point. Now D has 1 point and B has 1 point. Next, again the third value is also 0 and 1. Means B got another point. Now B has 2 points and D has 1 point. So B is 2, D is 1, A is 0, C is 0. Like that you have to do. Okay. After you do that, substitute the values of A, B, C, D in these formulas and find out the answers. Okay. A is 0, B is 2, C is 0 and D is 1. Like that we have to calculate based on the given vectors. That is how we do for the binary values. Now Hamming distance is nothing but what is the change happened. Okay, 101 is here, 110 is here. So 1 and 1 same, no need to do anything. 0 and 1, there is one change. 1 and 0, another change. So the answer is 2. Okay, Hamming distance is 2. Next, categorical variables, either the value will be true or false, like that. Okay, or they can be multiple categories as well. Like for example, code 1 can be given to female and code 0 can be given to male. So if the answer is female, it can be represented by 1. If it is male, it can be represented as 0. So basically you will do like this: distance xy, if x is not equal to y, means those are different points, 1 is assigned to it. If it is same point, means 0 is assigned to it, because distance will be 0 if it is same values, right? And ordinal variables is just like categorical variables, but there is an order here. That means if the designations of office employees are clerk, supervisor and manager and general manager, these can be assigned as clerk is level 1, supervisor is level 2, manager is level 3, general manager is level 4. Now if I want to find out the distance between the clerk and the manager, what we'll do, position of the clerk minus position of manager divided by n minus 1, that is equal to 1 minus 3 divided by how many positions are there? 4. 4 minus 1 is 3, so 2 by 3 is 0.66. So distance between clerk and manager is 0.66. Okay, if you do it with the vectors, we'll be using the cosine formula here. Okay, we'll see an example here. In the example, A is 110 and B is 011. If you want to find out the cosine value, first what we have to do, 1 into 0 plus 1 into 1 plus 0 into 1. That answer we will get as 1, and 1 will be writing it here, and root 2 we have to multiply. Okay, the norm of the vectors A and B is root 2, so we'll be multiplying root 2 with root 2 based on this formula. Okay, this is the norm we are calculating, xi squares and yi squares summation. Okay, means what we will do, 1 square plus 1 square plus 0 square. Here also we will do 0 square plus 1 square plus 1 square. In both cases we will be getting root 2 and root 2 here, right? Squares we do and we'll take the root, so you'll get root 2 and root 2, multiply them, you'll get answer 0.5. Okay, so the similarity between A and B is 0.5. Now there are 4 types of clustering algorithms. Let's discuss each one by one. So among the 4 algorithms, the first one is hierarchical algorithm, second one is partitional, third one is density based, and the fourth one is grid based. Now what is hierarchical algorithm? In hierarchical clustering algorithm, individual clusters are joined to form a larger cluster. So suppose that there are 3 clusters, I join these 3 and form a larger cluster, like that. Okay, that is the hierarchical clustering algorithm. It is also called as agglomerative cluster. Okay, first step, place n sample of data into separate clusters and determine the most similar clusters, merge the clusters and repeat. Okay, make these clusters, see which is similar, merge it and again repeat. If these both are similar, it will be just one single cluster like that. Okay, now there are three ways to do that. First one is you select the minimum distance. Okay, if you select the minimum distance, if we take an example here, the object is given object 0, object 1, object 2, object 3 and object 4, and the x and y values are given for each of these. Now if you have to find out which values are most closely related. Okay, object 0 to object 1, what's the distance? How do we calculate distance? By using the Euclidean distance. So 1 minus 2 square plus 4 minus 8 square, that's square root. Okay, when we do that, we'll get an answer. That answer we'll be writing it here. Okay, that is the distance between object 0 and object 1. Like that, we'll calculate the distance between object 0 and object 2, object 0 and 3, object 0 and 4. Like this and this, what's the distance? This and this, what's the distance? This and this and this, what's the distance? Like that, we'll calculate. Okay, so that is the same Euclidean formula we are using. 2 minus 1, what is 2 minus 1? 1. 1 square is 1 only, and 4 minus 8 is 4. 4 square is 16 plus 16. 1 plus 16 is 17. 17 square root, what is 17 square root? It is 4.123. Like that we have written. Like that, all distances will be calculated and we will be seeing which is the most least distance. Least distance here is the between the object 1 and 2. Okay, so object 1 and 2 is most closely related among all the other objects, so this one will be taken as one cluster. When you taken it as one cluster, we'll be writing it like this, 1 2 together. Okay, then again we'll calculate the distances. Now the question might come, how do you calculate the distance between 1 2 and 0? To calculate 1 2 and 0, what we'll do, we'll write 1 2 and 0 here, and we'll calculate distance between 1 and 0 and 2 and 0. Okay, if you calculate distance between 1 and 0, what is the means distance? 1 and 0, how can we calculate? The object 1 and object 0, what's the distance? 4.123. Then 2 and 0 you have to calculate. 2 and 0 already we have calculated. The object distance between 2 and 0 is 7.211. 4.123, 7.211. In between these two, you have to take the minimum. Minimum is this. So we will take 4.123. So the distance between 1, 2 and 0 is 4.123. Same thing we'll do with 1, 2 and 3, 1, 2 and 4. So when you do that, we'll get two more distances. We'll note down all these distances and find out the least one. When you find out the least one, see here we note it down and find out the least one. Least one we have got this. This means 1, 2 and 0 is closely related. So 1, 2 and 0 will be taken as a single group, and again the distances will be calculated using the same formula, and again we'll be finding out the minimum one, and we'll be including 3 and 4 together. See, 3 and 4, it was the minimum one, so 3 and 4 is one group. So now 3 and 4 is here, and none of the other are individually left, and the distances between this and this is left, and this is left, but we'll not calculate them. Why? Because the computation of question mark in table 8 is not needed, as no other items are left. So these are the two final clusters which will be formed. Okay, and if we see the dendrogram for the above clustering, in the dendrogram what we will do, the values will be writing object 0, object 1, object 2, object 3, object 4. So in our question, which was the first two objects which got merged? The first two objects which got merged is 1 2, right? After that, what came? After 1 2 came 0. Then came 3 and 4, right? So we'll do it in the same way. First 1 2 got merged, then came 0, then 3 and 4 came, and this whole thing is final answer. Like that we'll be writing. Okay, so this is how you will be doing the dendrogram. Okay, if we take the maximum value, in the above example we took the minimum value, right? Minimum distance between these two. Like that, if we take the maximum value, we'll get an answer separate here. If we get the average value, if we take the average value using this formula, we'll be able to see another answer. Okay, so there are three types in which you can do it: minimum, maximum and average. Another type is their mean shift clustering algorithm. In mean shift clustering algorithm, there will be data points present here. Okay, and we'll be using a window to pass through these points, and inside the window we will be finding out the average value, and whatever is the average value which is coming in the window, that one will be taken into consideration as one cluster. Okay, if the window has some other value other than the average value, and another cluster has a similar average value, we'll be combining these two clusters. Okay, so like that we'll be keep on doing. So that is the mean shift clustering algorithm. Advantages: no model assumptions, and suitable for all non-convex shapes. Only one parameter is there, which is the window size, and robust to noise, and no issues of local minima or premature termination. Disadvantage: selecting the bandwidth is challenging task, and number of clusters cannot be specified, and user has to specify this parameter. Okay, so it is a disadvantage. Next one is partitional clustering algorithm. The first one we discussed, hierarchical. Next is partitional clustering. It is the reverse. Okay, in the reverse, what will happen? K clusters are chosen, and every point to the nearest cluster is assigned to it. Okay, so we'll choose some clusters initially. This first cluster, second and third, and in between some points are there. Those points will be assigned to the nearest cluster which they are present to. Okay, and the algorithm is also very straightforward. Determine the number of clusters before the algorithm is started, choose k instances randomly, compute the mean of each instances, and find out the centroid. Again repeat the procedure until the centroid remains constant. We'll take an example and understand so that it will be easy. Okay, now see, consider the following data set. Here the sample data is given x coordinate, y coordinate, and objects are given. And in the question they have specified object 2 and 5 is to be taken with. Okay, now we'll take the object 2 and 5, and here what's the case? The object 2 and 5 will form one cluster. Okay, if you form object 2 and 5 as one cluster, the x coordinate will be 12 and 4. Okay, so 12 and 4 will be the clusters x coordinate, and 6 and 4 will be the clusters y coordinate. Okay, now we'll have to find out the centroid. Okay, how do we find out the centroid for cluster 1 and cluster 2? Okay, so this is the cluster 1 2, and this is the second cluster, which is 5. Okay, now what we'll do is, first object we'll consider this object. We'll see if this object is closer to this one or this it is closer to this one. Okay, so we'll find out the distance, 2 minus 4 and 4 minus 6. Okay, when you do that and do the square root and square, we'll getting root 8. When you do the same thing for the next one object with 5, 2 minus 12 and 4 minus 4, that one we will do, we'll get the value as 10 here. And obviously root 8 is less than 10, so this the object 1 is assigned with object 2. Okay, so 1 is assigned to object 2. Like that we'll calculate for 3, 4 and 5 also, not for 5. 3 and 4 will calculate. So in each of these cases, for the object 3 also it is closer to the object 2, and object 4 is closer to object 5. So two groups are formed, 1 2 3 and 4 and 5, right? Two groups are formed, so we'll be taking those two groups, object 1 2 3, and second object has 4 and 5. Okay, and we'll calculate the centroid also. Centroid means find out the sum, 4 plus 2 plus 6, that is equal to 12. 12 divided by 3, that is 4, right here 4. 6 plus 4 10, 10 plus 8 18, 18 divided by 3, it is 6, right here 6. 10 plus 12 is 22, 22 divided by 2 is 11, right here. 4 plus 4 is 8, 8 divided by 2 is 4, right here. Okay, next, after doing this, again we'll find out if the object's distances have changed or not. Okay, now what we'll do, we'll compare with these centroids. Okay, centroids you have to compare. Previously only two values were there, so in the we are directly comparing with the values itself, but actually we have to compare with the centroids. Okay, centroid values, in this case obviously it is one value only, so the centroid will also be same only, but here it will be different values, right? So this value and this value to compare. Again, from this to this, what is the distance? From this to this, if you find out the from this to this, if you find out the distance, 2 4 and 4 6, the distance we get as root 8. And if I find out this with this distance, we will be getting as 9. Again this is lesser, which means this will remain in the cluster 1 only. Second, we'll calculate this with this and this with this, then we'll see which is lesser distance. Lesser distance, again it came as 8 only, so we'll be keeping it as such in the cluster 1, right? Again we'll do the same thing for the this object, 10 and 4 with this value, and 12 and 4 with this value, and with this value and this value. 4 calculations we have to do, and we have to see if 10 4 is closer to this or this, 12 4 is closer to this or this. When we do that, we'll be able to see that it is already, whichever it is there, that is the closest ones. In the cluster 1 these are the closest, and cluster 2 these are the closest. So we'll get our final clusters, cluster 1 and cluster 2, with the following points. Okay, this is the k-means algorithm. The third one is the density based methods. DB scan is the method which is used to form the clusters based on density. Okay, density means how much closely they are there. This is more dense and this is less dense. Okay, less dense is also called as sparse. Okay, sparse means lesser dense. Okay, lesser dense, and more dense means more dense only. Okay, now there are three types of points are there. Suppose I choose one point here and find out a radius. In this radius, if I find out a circle, in this radius how many points are there, that will be calculating the density. If this point is greater than m, it is more dense. If it is equal to m, it is okay. If it is less than m, it is less dense. Okay, so minimum number of points that should be there in the circle, minimum number of points that should be there in the circle is m. If it is lesser than m, that means it is a core, it is a noise point. If it is equal to m, it is border point. If it is more than m, it is the core point. Okay, means it is more closely related. Okay, now the main idea is that every sample should have at least minimum number of neighbors. Okay, the m value should be maintained. Okay, and the following measures are used: direct density reachable, densely reachable, and density connected. In this case, point x is directly reachable from y if it is a neighborhood. if x is directly reachable from y, x is the neighborhood of y, means it means that if the value of x and y are both within the same circle, that means x can be directly reached from y, right? So that is the thing which we are taking into consideration, direct density reachable. Densely reachable, the point x is densely reachable from y if there is a set of core points that leads to y from x. Directly we can't reach, but there are some core points through which we can reach. Okay, density connected, it is density connected if z is a core point and thus points x and y are densely reachable from z. X and y we can't reach directly or densely, but there is a point z. Okay, z point is there, from z we can reach to this or this, but we can't reach through z to this. Okay, like that. That is the third one, which is density connected. And the algorithm is also very simple. Randomly select a point p, compute distance p with all the other points, find all the points from p with respect to its neighborhood, check whether it has minimum number of points. If so, mark it as core point. If it does not have, it is not the core point. Okay, if it is a core point, new cluster is formed. If it's a border point, algorithm moves and next point is marked. If it is a notch point, it is removed. Okay, then merge the clusters and repeat the same process until no more new clusters are formed. Okay, so that is the density based approach. Next we have the grid based approach. In grid based approach, it partitions space into cells and fits the data in it. So empty spaces there here, so we'll be forming some cells here. Inside these cells, whatever points are there, we'll fit each of these points in these grids. Okay, that is the grid based approach. To understand grid based approach, you need to understand three things: subspace clustering, concept of dense cells, and monotonicity property. Now, what is subspace clustering? Suppose there is a employee, that employee is become sick, that employee has gone to hospital. In the hospital, he's given his age and his blood group and his name, but also he is giving his address. Okay, but the doctor does not require its address, because address will not help in finding out the cause of the disease, but blood group will, the age will, right? So address is irrelevant there. So the things which are just relevant, forming such subspaces that are actually needed, is the key point here, which is subspace clustering. Next is concept of dense cells. Clique determines if the cell is dense or sparse. There is a threshold value. If it is exceeding that value, it is dense. If it is not, it's a sparse. Okay, and the algorithm is here. Define a set of grid points and determine the threshold value. Merge the cells that are adjacent and form a list of grid cells for each subspace as output. The third one is monotonicity property. Here it uses a priori algorithm. If one subset is infrequent, means it is not frequently occurring, no matter how many supersets you form from it, it will all be infrequent. Or if this is formed from another bigger set, that will all be infrequent only. Both the ways it is possible. If it is frequent, it is frequent. Both the cases it is frequent. By frequent and unfrequent, I mean that whatever the values which we are getting here, that is relevant or not. Okay, now there are two stages. First is identify the dense cells, merge the dense cells C1 and C2 if they share the same interval. Okay, and we have to repeat this until no more dense cells are formed. And stage 2 is merge of dense cells into cluster, carried out in each subcell using maximal regions to cover the dense cells, and maximal region tries to cover all dense cells to form the clusters. Okay. The second half of the module is related to the reinforcement learning. Okay, what is reinforcement learning? It is a type of learning where the agent gets rewarded for the correct move and punished for the wrong move. Suppose there is a robot standing here, and it has two options: move to the left or move to the right. If it moves to the right, it is the correct move, we will be getting +1. If it is going to the left, it is -1. So our robot obviously will choose the greater reward. It will go to the +1 state. So that's the correct move which we have desired also. So that kind of learning is called reinforcement learning. And reward is a positive reinforcement, while punishment is negative reinforcement. It can be used where complete info about environment is not available. We know some information about the environment. There is some blockage here and there is some danger here, and robot has to move from the start state to the end state. The complete information is not known. In that case, use reinforcement learning. If the complete information is known, there is no point of using reinforcement learning, because once something is known, you can directly use the classifier method which we discussed in the previous modules, right? What are the characteristics of reinforcement learning? Before that, understand this graph here. In this diagram, we have a starting point. From the starting point, we have to go to the goal, avoiding all the black points and the gray points. Okay, that is the reinforcement learning. If it goes here, a negative point will be assigned so that it will not go again here, like that. Okay, and it is sequential. Step by step, we are going, learning, coming back and going. That is a sequential decision making. Second is delayed feedback. Once we go here, we don't know how near we are to goal unless we reach the goal, right? So at the end, we are getting the reward. That is called as delayed feedback. And the agent actions are interdependent, as any action affects the subsequent actions. If the robot goes here, the next time it will not go here. right? So it will avoid this. How it is avoiding this? Because previously it has gone here and got negative reward, so the actions will affect the other actions, the future actions, right? So that is the third point. And the fourth point is time related. All are associated with time stamps inherently, as all actions are ordered but as per the timeline inherently. Okay, these are the four characteristics. So now, what are the challenges in the reinforcement learning? Reward design is a big challenge. Where to keep the reward, that is a big challenge. Absence of model is a challenge. We don't have specific rules related to it. Partial observability of the state, we cannot see the all states at the same amount of at the same point of time. Time consuming it is, and it is more complex. Okay, now what are the applications of reinforcement learning? Industrial automation, resource management applications, and traffic light controller. At what point of time what vehicles is to be given, so that the given as a go, so that the traffic is reduced, and personalized recommendation system like news and bidding for advertisement. Okay, what is the differences between reinforcement, supervised and unsupervised learning? See, in reinforcement learning we do not have any supervisor, there is no data, there is no feedback, and the action affects the next input data, and no target values are there. Okay, so it is all unknown. In supervised data it's all the opposite, everything is known. In unsupervised learning, mapping from input to output is present here, and the feedback we are getting, but in unsupervised it is even worse. The mapping is also not present and feedback is also not there. Okay, now what are the components of reinforcement learning? Very important question from the exam point of view. There are four components. First one is environment, second is agent, action, and rewards. Okay, so environment means what? Environment means earth. Okay, earth. We are living in earth, right? And you go to a job, you earn money, so you are the agent. Okay, and earth is the environment. Action is you doing the job, reward is you getting salary. Like that only will train a robot in a specific environment with the actions and rewards. That is called as the components of reinforcement learning. And there are two types of problems: learning problem and planning problem. Learning problem, environment is not known, and planning problem, environment is known and some policies exist. Means the robot will know to avoid some things and do some things more favorably. Okay, if two options are there, which option to choose? Some policies are defined, choose this one or this one, like that. Okay, so that is the planning approach. Environment, where all the action happens. And what is the state? State is in currently which state you are. You are a student, right? So input for the reinforcement learning is state and the output is action. Illustration of various type of states is defined here. From A, if you go to up, you will go to B. If you go to up, you will go to D. If you go to up, you will go to F. If you go to D, down from D, you will go to G, which is the goal state, like that. These are the different states: state A, state B, state C, state D, state E, and so on. Okay, and these are the actions, whether you are going up or down, and the reward is reaching the goal. Okay, now goal node is the final node, non-terminal node is the middle nodes like B, E, and D, and the starting node is A. Okay, that is a terminal node, starting node. Okay, now policies are the roles of algorithm, means how the agent should behave on specific situations. There are two types of policies: deterministic and stochastic. Deterministic means it will always give the same answer. Whatever is the state, if it is in the state 5, it should go to state 6, like that. It will be constant. That is deterministic. We know for sure from one state which state it will go. Stochastic means it depends on the previous states where it has gone. Based on that, the next state will be defined. That is stochastic policy. Okay, and rewards are nothing but based on system's performance. Good or bad rewards can be there. And two types of rewards are there: immediate and long-term reward. Immediate reward means one step taken, if it is right, you will get a reward. Second type of reward is long-term. One step you take, nothing you will get. Two step you will take, nothing you will get. Three step you will take, nothing you will get. Unless you reach the final goal, then only all the previous steps rewards you will get. That is the long-term reward. Okay, next topic is Markov's decision process. Okay, so let's understand Markov decision process using an example. So suppose that there is a university A and university B. In university A, 80% of the students go for university B for higher studies, and from university B, 40%, 60% of the students come to university A for higher studies. That whole thing can be determined by using this diagram. Okay, from A, 80% have gone, so 0.8, and from B, 60% have gone to A, so it is 0.6%. And if 80% are gone from A, how many are remaining? 20%. If 60% are gone from B, 40% will be remaining. By using this diagram, we can form this matrix here. How many are remaining? That is 0.2. And how many are remaining? 0.4. How many have gone? 0.8. How many have gone? 0.6. Based on this, we can calculate the future years, what is the trend most likely to be based on the previous states. Okay, now for example, if we take an example, this is the starting states. Okay, they have given that this is the states: 80% go to the university B, and from the university B, 60% come here to the university A. Now After this is given, what you have to first calculate is the starting distribution. Also they will give E60 and 40. Take 60 and 40 and multiply it with this, so you will get two answers, which is 28 and 72. So next year 28% might go and 72% might come, like that it is. Okay. And if we keep on doing this for then even next year also, 0.28 and 72 you'll have to multiply with the same value, 0.2, 0.8, 0.4, 0.6. You'll get 34% come from university A to B, and from B to A it will be coming, 65% will be coming. So like that it is changing. Okay, it is observed that the hold on the student by the university changes. This is where the Markov chain is used, and this is an example of it. Okay, now the components of MDP are, there are 5 components: the states, actions, rewards, policy, and value. Okay, it performs the following actions: observe the current state, whichever you are there in the current state, observe it, perform an action. When you perform an action, you will get a reward associated with that action. It can be either positive, it can be either negative. Then enter a new state based on that reward. Okay, the aim is to maximize the rewards. Okay, that is the main aim of Markov's decision process, MDP. Okay, next is multi-arm bandit problem and reinforcement types. There are two subproblems in this: prediction of the total reward or return, and finding the actions that maximize the return. Now, for example, just assume that there is a you go to a gambling center. In the gambling center, there are 5 slots. In these slots, you can pull any of these slots. If you pull any of these slots, some random value you will get. Like for example, you can get $1 to $15 you can get. Okay, if you pull this, you can get any value in between this. If you pull this, any value you can get in between this. Now the question is, which one I have to pull so that I can get the maximum reward? You cannot say that. Why? Because you don't have any knowledge how these things work and what are the biases present in the behind. So you'll just do trial and error method. You'll pull all of them and note down what are the values you have got. Okay, now after noting down all the values you have got, next time when you do, it is most probably that the lever which has given the highest reward, that one you will be preferring than the other ones. Why? Because you believe that something might be there that it is giving more reward in this one, right? It is designed specifically that it is giving more reward, but that you cannot be sure of it because you have not seen what is in the behind algorithm, right? But still you will choose this one. Why? Because comparatively it has given more here. And suppose you got here again more. Okay, what you'll do, you'll come again, keep doing here only, here only, here only. Why? Because from the current information, this has been giving the most answers, not answers, the money it has been giving more, so you'll keep on doing this only. But you could be wrong also. What you're following is the greedy approach. Whatever is giving more, you're taking that. But that is not always true. Why? Because what if you have got here just 8, and here you have got 1 2 4 5, you have got 8, again you do, you got 8, again you do, you got 9. But what if you have got 2 here, and here it was the highest, only the first one was lower, second you will got 10, then you got 20, then you got 30. You could have got this one, but since you are greedy, you are just doing this one and you did not risk your chances for trying out the other ones. Okay, so there are two methods. The first one is exploitation. Exploitation means whatever you are seeing, that one you are exploiting and going. Okay, means taking more and more. Second is exploration method. Exploration means you are trying all of them and seeing which is getting more reward, and based on that you are switching back and forth. Okay, you will not always stick to one same result. Okay, that is the overall thing which is explained in the multi-arm bandit problem and reinforcement types. Okay, so this is the theory part, you can go through it. Next is the reinforcement types. There are the few reinforcement types: value based, policy based, hybrid, and model free. Now value based means the main aim is to optimize the value v so that maximum returns we can get. Okay, that is value based. Policy based is based on a policy we are optimizing to get the rewards. Okay, and actor critic methods, it is the hybrid method which combines both value based and policy based. In value based we have a discount factor gamma, and in policy based we have a pi, which is a strategy. Okay, in both of these we are optimizing these two to get the maximum rewards, and hybrid mode combines both of them. Model based approach, model is constructed. Model free approach, there is no model, we are just keep on going and observing and moving forward. Okay, now which is the algorithm to be selected? Based on the availability of the models, environment, and nature of the updates, the decision is made. Okay, based on this table. If the model is present and the environment is static and the on and off is off, in this case best is to use the dynamic programming. Like that for the other ones also it's there. Okay, now model based will be seeing. What is a model based? Means passive learning. There is a model present, there's an environment known, everything is known. The aim is to take the action AT, transit from the current state to the end state, maximizing the reward. Okay, now for that we'll be using the value function, and the value function will be having two things. If a value function is applicable for the state, it is called state function. If it is applicable for the action, it is called a state action function, and for each of these there is a separate formula. Okay, we'll be using this to maximize the value of state, and we'll be using this to pick up which function we want to choose. Okay, now to solve the reinforcement problem using the conventional method, there are two types of algorithms: value iteration and policy iteration. In value iteration, we'll be choosing each value better than the previous one. Okay, and this is the algorithm for it. Next one is the policy iteration. In this, two things you have to specify, which is first evaluate the policy, then improve the policy. Policy means given one point of time, there are n number of options. Which option you will choose, that is determined by policy. So that policy we are designing, first we'll evaluate the policy, then we'll improve the policy. Okay, for evaluating the policy and improving the policy, we'll be using Bellman equation. First we'll take a random value, and then we'll keep on observing and changing the values using this algorithm, and we'll be finding out the best policy. And that best policy we are improving even further by using the Bellman's equation only. Okay, by using this formula. Okay, so we'll get a best policy if you follow this approach. Next is model free methods. In model free method, there is no complete knowledge of environment. Okay, either the reward is determined after reaching the end or at each step. If we get the reward after reaching the end, it is Monte Carlo method. If we are able to get the reward at each step, it is temporal difference method. Okay, so in Monte Carlo method, all episodes should terminate. Episode means action. Okay, no matter from where we start, episode should end. Okay, means a path whichever is going, that should end. Okay, it should reach the goal. Next is Monte Carlo method use value action functions. Okay, and these are incremental. At the end, when we reach the goal, then only we'll be getting the final reward. Okay, and it collects the rewards in the end, and it is used to predict the future rewards. Once it uses means it follows the algorithm and reaches the end. After reaching the end, whatever the value it has got, that value will be considered for the next iteration. Okay, like that it is. And this is the formulas for the Monte Carlo method. And the algorithm is very simple. 4 steps algorithm. For a policy pi, select the state S, generate an episode. Episode means a path. Generate a path, compute the average returns, and update the returns and start a new episode. Repeat it for all the episodes, means for different types of paths. Next is temporal difference. Okay, in temporal difference, state action is updated for every step. Here, after reaching the end, it is updating, right? But here it is every step it is updating. The difference is, it is easy to understand Monte Carlo and does not exploit Markov principle. It requires termination in episode. Here it exploits Markov principle and does not require termination. Markov principle, you remember that university students, they are going from A to B and B to A, it is coming, and year by year it is changing. That is the thing which is getting used in temporal difference method. Okay, and this is the algorithm for it. First, set a policy, set the value of the state as 0, and state should belong to the set of states. Repeat for each episode, initialize the initial stage and choose an action. Okay, choose an action and observe the new state and the new reward, update the values and repeat it. Okay, until the S state is terminated. Next one is Q learning. Q means quality. Quality learning means if you are in one state, there are 3 states in front of you. Which state you will go? I'll go to the state which has the highest quality. Now, what is the quality? Quality means the most reward you will get. How you will determine which quality you have to go, which state you have to go, and how a quality is determined. By using the 4 things to get started: starting state, action, reward, and new state. By using these 4 things, we will be calculating the quality by using greedy softmax or softmax plus approach. Okay, and there is a learning policy and update policy also, which will keep on updating the new quality values. Okay, and the updation procedure is pick any random action on state I, generate a new state, and get the reward. If the reward is better than the previous reward, update it. If it is not, don't do it. Okay, and that's the same thing which is happening here, and we'll find out the optimal quality states at each point, and then we'll be following that path to reach the goal with maximum rewards. Okay, last one is SARSA learning. SARSA means it is based on epsilon greedy approach. Remember in the multi-bandit problem, I have showed you that which lever if you choose, that will give the more reward. In the first, it gave this lever is giving more rewards, so you'll keep on doing this. But in epsilon greedy approach, you'll be also exploring in between. 80% of the times you'll be using this, 20% of times you'll be exploring others also, so that if something else is better, you'll be going for that. Okay, so SARSA comes from this. This is the state, action, and reward. This is the next state and the next action to be taken based on the previous action and rewards, and each is a quality state, and new quality will be taken after finding out the next states based on the reward. Now, based on this approach, if you go, it is called as SARSA learning, and this is the formulas which are going to be used to find out the new quality values. Okay, So the same things will be done here, and we'll be finding out the new episodes and new paths, and finding out the maximum reward path which I have to reach from the start state to the goal state. Okay, that's all for the module 5. If you found this video helpful, please like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.